Hey, this is lesson 8.6. We are graphing systems of linear inequalities, and your objective is to graph systems of linear inequalities. Let's go ahead and get started. Right here are your steps for graphing linear inequalities. Make sure you go ahead and write these down, and I will explain them on the slides as we go. Okay, so I'm going to go ahead and go to the next slide, pause the video, get the steps written down. Okay, so graphing linear inequalities. The very first thing that we need to do is graph all of our lines. Okay, now we need to remember back to when we did linear inequalities and graphing them, and we need to remember things like solid lines and dashed lines and which way to shade and all that kind of stuff. Okay, so I'm going to go ahead and get my red pen here, and the very first line that I need to graph is y is less than 2. Okay, so that's going to be a dashed line because it doesn't have the or equal to. And I'm going to go ahead and use 2 as this red line right here. So I'm going to count by the red lines. Here's 1, here's 2, 3, and so on. Okay? So y is less than 2. That's going to be a dashed line that goes right across here. Okay? Now in your steps it says you can use something called a comb technique, or you can use colors. Okay, here's what I mean by the comb technique. Now normally, if we would have just been graphing this inequality, we would have shaded all this stuff under here, because all those things are where y is less than 2. So I'm going to do what's called the comb technique, and just go ahead and put little lines that are pointing the way that I would shade. Okay? So these combs are telling me that the shading would go downward for this line. Okay? Now, I'm going to go ahead, and you'll see what we're going to do with this at the end. So now I'm going to go ahead and graph the next line, the green one. Okay, x is greater than or equal to -1, so my line needs to be at -1, and it's a solid line. Okay, and now I'm going to put comb marks toward where I would shade for this one. So if it's greater than or equal to -1, that's all this stuff all the way over here. So now I'm going to put my comb marks facing this way. Okay? Now notice that over here I don't have any green comb marks that are pointing this way. And up here I don't have any red comb marks pointing up this way. So that means these two areas cannot be solutions for the system so far. So far the only possible solutions for the system are numbers that are down in here where the comb marks are pointing toward each other. Okay? So right now, if I was just to graph those two, then the solutions would be all this stuff in here where the comb lines are facing each other. But we've got one more, so we need to do our blue line. And it's y is greater than x minus 2, so I'm going to put a dot at -2 on the y-axis. Our slope goes up 1 and over 1. And up 1 and over 1. Okay, and we're going to go ahead and make sure that that's a dashed line running through these points. Okay, and we're going to use the comb technique. We want numbers that are solutions to this. So if we plug in 0, 0 to this equation, we're going to ask, is 0 greater than 0 minus 2? Okay? And 0 is greater than -2. So 0, 0 is a solution. So that means that my shading should be up this way normally, okay, above my line here. So I'm going to put comb marks that show that again. So the shading would be this way. Okay? Now again, notice where the blue ones are pointing. Okay, the blue ones are pointing this way. Well, I've got red ones pointing this way and blue ones pointing here, but there's no green ones pointing this way. So this cannot be a solution region. Okay, this up here, the only thing that would be shaded up here is the blue lines would go that way. Up in this area, the only things that would be shaded are the blue and the green lines, because the red lines aren't facing that way. If I go down here, the only things that meet up are the green lines and the red lines, because the blue lines are shaded the opposite way. So my solution to this is where all these kind of come together right here in the middle. So that is where my solution region is going to be. Is all this stuff right in here. So I'm going to go ahead now and shade all that in. Now notice where I shade. I'm shading kind of this little triangular region right here, and my lines are boundaries to those. Okay? So this green line, I can't shade outside the green line, I can't shade below the blue line, and I can't shade above the red line. Okay, so I gotta shade all this area in between here. And that is my solution region. Okay? So if you're doing colors, that would be where the colors all cross each other. Or if you're doing the comb method, it's where all the combs are pointing toward each other. Okay? So when we draw this out again, you shade, I want you to shade the actual solution region for the system in. Okay? So this is all solutions for the system. Alright, let's move on to another example. Okay, and here's another one. So we're going to go ahead and do the red line first. We got y is less than 3. So that's going to be up here at 3. And it's going to be a dashed line going across. Again, I'm using these red lines as 1, 2, 3, 4, and 5, so on. Okay? Well, that shading says y is less than 3, so it would go down this way. Now we got y is greater than 1. And again, it's another dashed line. And the shading would be above that because it's greater than 1. Okay? Well, the red shading, the red shading would go all the way down in this area, but there's no blue below the blue line. So that can't be a solution region. If I go up here above the red line, the blue would be shaded up here, but the red goes the other way. So the solution region is right here in the middle where they meet. So we're going to go ahead and color that all in. So this in here is my solution region for that. Okay, now we didn't talk about this last time, but there are boundaries to our region here. The lines, all of our lines are our boundaries. So that means that this line is dashed, so this line is not included. So none of these ordered pairs where y equals 3 are solutions. And none of these ordered pairs where y equals 1 are solutions. Okay, it's got to be the spaces in between here, not including the lines, because the lines are dashed. Alright, and we got one more example. So here we got a 4-banger, 4 problems all in one. So first one is x is greater than or equal to 0. Okay, so that's a vertical line where y equals 0. So I'm going to make sure that I know, and that's a solid line, so I'm going to make sure I color this in nice and dark so I know that this is a line that I need. Okay, and that shading is bigger than 0, so it would go this way. Okay, next one, y is less than or equal to 0. Well, that's a horizontal line where y is 0, so my red line is going to be the x-axis. And it says it's greater than or equal to 0, so that's shading above the line. So far, the only places my combs intersect are up here in this first quadrant. So this is the only possible places we can have solutions. Now my green line is less than or equal to 2. Again, that's another solid line at 2 this time. So that's going to be right here. And we are less than or equal to, so we're going underneath the line. So now with those 3 equations, we've got our solution region would be just in this little box right here. And we got to graph our last line, the blue one. We go up to 3 for our y-intercept, and we're going down 1 and over 2. So down 1 and over 2. Down 1 and over 2. Okay, and we will connect those to make our line. And it says less than, so I gotta think to myself again, test 0, 0. 0 is less than or equal to 1/2 times 0, or sorry, negative 1/2 times 0 plus 3. Well, negative 1/2 times 0 is 0, plus 3 is 3, and 0 is less than or equal to 3, so that shading goes underneath my line. Okay, so now my solution region is bounded by all 4 lines, and it's where all the shading intersects. So I got my black pointing this way, red up here, green down here, and blue this way. So my region is this little quadrilateral right here. Okay, that's where all my shading intersects each other. And again, it's got to be bounded by my lines. Okay? Well, think about this now. Solutions to this, all the lines are solid. So that means anything on the quadrilateral is a solution. So, like, let's take the point, oh, I don't know. Let's go with 1, 2, for example. That would be right here. Okay? 1, 2 is a solution to all those. Okay, if I look at that ordered pair 1, 2, the x is greater than 0, the y is greater than 0, the y is less than or equal to 2, and if I plugged it into this inequality, it would work. So this point, even though it's on a line, is still a solution because the line is solid. And anything in here would also be solutions. Alright, and that's your lesson on graphing systems of linear inequalities. So good luck on the homework.